All right, multiplying polynomials. You guys have done this before. The problems will get elevated to the Algebra 2 level, of course. Why wouldn't they? But it follows the same idea of multiplying of polynomials that you guys have done before. Foiling, that's multiplying polynomials. Distributing, that's multiplying a monomial with a polynomial. So it's the same idea. Here we have a binomial, 2 terms, multiplied by a trinomial, 3 terms. So we're going to start with that first term, the 2m, and we're going to distribute it to the second polynomial. So the 2m is going to multiply to 1, 2, 3 terms. So 2m times 3m, 2 times 3 is 6, and then m times m to the third power. So here's where your exponents will change. If you're multiplying variables together, you're going to add the exponents. So that's an m to the first. If it helps to write it in, go for it. M to the first times m to the second power is m to the, but we actually add 1 plus 2 when we get to the third power. Now we're going to distribute to the next term. We're going to be very careful with our signs. It's a positive 2 times a negative 4. So if you notice, I'm multiplying coefficients first. 2 times negative 4 is negative 8. And then m to the first times another m to the first. M times m, we add our exponents and we get m squared. Now we are going to multiply to the last term. 2 times a positive 2 is a positive 4. And the m doesn't have any m's to multiply with, so it just kind of tags along. It's going to be a 4m. So we have taken that 2m and we distributed it to the second polynomial. We're going to do the exact same thing with the positive 5. So positive 5 times a positive 3m squared. Now, how you organize your work is up to you. Here's just one thing you could do. I don't always do this, but I'll just show you a way to organize it. 5 times positive 3, I can say I'm going to end up with an m squared. So 5 times 3 is 15. And then the m squared is just going to carry along. And what I just did is I put it right underneath its like term, the m squareds. When we're done doing our multiplication, we will combine any like terms for our final answer. It just helps us to see kind of what's going together. All right, now we're going to distribute. We have a 5 times a negative 4m. So pay attention to your signs. 5 times negative 4 is negative 20. And that m just carries along. And then 5 times a positive 2 is a positive 10. So final answer, combine any like terms starting with your highest exponent. M to the third power, you can see we don't have any other m to the third power, so that's just going to stay as 6m to the third power. And then your m squareds, here they are, just lined up vertically. Negative 8m squared plus 15m squared. So be careful on these. We're no longer multiplying. Your exponents are not going to change. This is going to remain an x squared. We're just going to add or subtract the coefficients. So negative 8 plus 15 is a positive 7, and the m squared just tags along. It does not change. 4m plus a negative 20m, or 4 minus 20, however you want to see it, is a negative 16m, and that plus 10 does not have another constant to combine with, so here we have our final answer. All right, our next example, if this looks a little bit different to you, well, it should, so nice job noticing that. One, we have more than one variable involved, so we'll just be aware of that. Just means we have to be careful. But we actually are multiplying 3 polynomials. Here is a binomial times a binomial times a binomial. So when we have this, we're just going to follow order of operations, which says multiply left to right. So we're going to multiply just the first 2 together. We'll get that answer, and then we'll carry down our last polynomial to multiply. So when you multiply polynomials together, distribute the first, mn times mn. The m's multiply to give you m squared, and the n's multiply to give you n squared. Now we're going to distribute to the second term. That's just going to, mn times a negative 2 is negative 2 mn. All right, 1 times mn is a positive 1 mn. I'm just lining up those like terms again. If you like this method, great. If not, you don't have to organize your work this way. 1 times negative 2 is a negative 2. So I want to combine any like terms to get this first multiplication simplified. The m squared, n squared had no like terms, but the mn's have like terms. So negative 2 plus 1 is a negative 1, mn, and that minus 2 had nothing to combine with. So I'm going to go ahead and throw parentheses around that because we're going to bring down our last multiplication of mn plus 4. All right, now let's do some more multiplying. Multiplying polynomials is just distributing. You just distribute one term at a time. So m squared n squared times mn, add your exponents. We have an m to the third power, n to the third power. M squared n squared times a positive 4 is a positive 4 m squared n squared. All right, we're done distributing that term. Now let's distribute this next term. Negative times a positive is a negative, and mn times mn is m squared n squared. So again, I kind of thought ahead for a second. I knew that was going to be a like term with this 4 m squared n squared, so I just put it right below. We're not done distributing. We have a negative times a positive, so it's going to be a negative. And then mn times 4 is just 4mn. All right, we have one more term to distribute. We have a negative 2 times mn. That's just a negative 2mn. Again, I'm just lining up like terms. And then negative 2 times a positive 4 is a negative 8. Our final answer we will get from combining any like terms. This m cubed n cubed had no like terms, so that's going to go first. Then we have m squared n squareds. 4 minus 1 is a positive 3 m squared n squared. And then our mn's to the first powers, we have these. Negative 4 minus 2 is a negative 6 mn. And just to point out again, now that we are combining like terms, none of these exponents are changing. They only change if you're multiplying, and then when we get to our division lesson, you'll see how they change with division. All right, that minus 8 has no like terms to combine with, so that is just going to come down. So again, I don't think you guys would say this is the most challenging math that you've ever done, but it's real easy to make small mistakes, so you just have to be extra careful.